Hello guys, we are on 6.2. 6.2 says determine the general solution of tan x equals to 2 sine 2x where cos x is less than 0. Okay, we are going to try to determine the general solution there. Okay, with the general solution we are going to try to simplify this equation to a single trig ratio. Okay, let's try that. I'm going to take this expression to the other side. Okay, then I'm going to have tan x subtracting the 2 sine 2x equals to 0 there. Okay, the tan x, there's an identity. Okay, the identity of sine x dividing the cos x there. Okay, even the sine 2x is a double angle. Okay, then I'm going to say 2 into 2 sine x multiplying the cos x there. Okay, we are having it like that. Okay, then we just simplify. Then we're going to have sine x over the cos x. Negative 2 multiplied by 2, that gives us negative 4 sine x multiplying the cos x. Okay, we are having something of that magnitude. Then here we're going to need the algebra when it comes to fractions. Okay, everything here divided by 1. Okay, sine x multiplied by 1, we are having the sine x. Okay, cos x multiplying 4 sine x multiplying cos x, there we're going to have 4 sine x multiply the cos squared x. Okay, this cos x going to multiply this cos x. Okay, then we are having the division there, cos x multiplying the cos x multiplying 1, there you're going to have cos x. Okay, equals to 0. Okay, then we are having something of that magnitude. Okay, then we further cross multiply there. Okay, this whole lot of thing multiplying 1, we have the sine x, then subtracting 4 sine x cos squared x there. Okay, cos x multiplying 0, there we have the 0 there. Okay, here we are having sine and here we are having sine. Okay, we can take it out. They say it's a common factor. Then we are going to have sine x. Here we remain with 1. Here we're going to remain with 4 cos squared x equals to 0. Okay, then here we can abuse the 0th law. Okay, we are having two terms which are multiplying, then one of them, or either each of each each one of them should be equals to 0. Okay, then we're going to have sine x equals to 0, or 1 minus 4 cos squared x equals to 0. Okay, this one needs to be simplified further. Okay, then I'm going to take this negative 4 cos squared x to the other side. Okay, then I'm going to have 1 equals to 4 cos squared x. Okay, then here I want to deal with the 4, then I divide by 4 both sides. Okay, then I'm going to have 1 over 4 equals to cos squared x. Okay, you can even arrange it in this manner, no problem. When you swap, no change of signs. Okay, so now we want to deal with the squared there. Okay, remember we're looking for cos x, not cos squared x. Okay, then we introduce the reciprocal there of 2, which is 1 over 2 both sides. Okay, 1 over 2 is the square root. It means we introduce the square root both sides. Okay, but remember the square root is plus or minus. Okay, then here we should have the plus or minus. I hope it's visible. Okay, and here we got the conditional restriction. They say the cos x should be less than 0. It means we're going to take the one which is negative. Okay, then here we conclude to say therefore the cos x, we take the one of negative. Okay, when you punch this on the calculator, you're going to have what, 1 over 2. Then we take this one and of the negative, we ignore the positive one because of the restriction. Okay, then we are going to deal with this uh, with this equation separately. Okay, let's start with the sine x equals to 0. Okay, we are having the sine x equals to 0 there. Okay, the sine x equals to 0, sine x equals to 0. Okay, what happens here is that we are going to look for the reference angle. Okay, the reference angle is an acute angle. Okay, in the first quadrant. Then here, for us to get the reference angle, it will be like we are trying to solve for x here, okay, or to solve for whatever is going to be here, okay. Then you know very well that when we are solving for whatever for this angle, actually, literally it's like we are taking this side to the other side, whereby we are going to introduce the arc, okay. Yes, so then we must have the arc of whatever this here, then we're going to have the arc of what? The sine arc of 0, then which should give us we punch it our calculator, then we must get 0 degrees there, okay. Then you now we must go to the quadrants, okay. Then we ask ourselves, this is 0, okay. 0 in most cases is positive, okay, but it's neutral. It can even be what? It can even be negative, okay, but we will just consider it as positive, okay. Then we ask ourselves, which quadrants does actually is sign positive. Remember very well that it's the first quadrant, then the third quadrant. Then we start with the first quadrant, okay, with the first quadrant. Then here you take whatever this is. In this case, we're just giving the x. Then we say the x equals to, okay. Then in the first quadrant is just an acute angle. Then we take whatever this here, okay. Then we are having 0 degrees plus k multiplying the 360 degrees, where k equals to, I mean, k is element of integers there, okay. Sorry. Then we want to analyze k multiplying the 360 degrees thing, okay. This 360 degrees is the period for a sine graph actual, okay. A period is the degrees whereby the graph completes one cycle, okay, or the function completes a circle or a wave, okay. Then we want to understand, or what does actually this mean, okay. Let's have an explanation for that, okay. Let's have the Cartesian plane like that. We are having the Cartesian plane like that, okay. We're having the Cartesian plane like that. We know that the sine graph completes a cycle after 360 degrees, okay. Here we're going to have the 90 degrees here, 180 here, 270 degrees here, 360 degrees, okay. 90 gives us 1, okay. 270 gives us -1 there, okay. When you press side 90 on your calculator, it gives what? It gives you 1, okay. That is the solution in the first cycle, okay. We can have another solution in the next cycle or next wave, okay. Even here, whatever is going to be here, when you press it, it should give you 1, okay. Here we must have 450, okay. 450. When you say sine 450 degrees, it must give you what? It must give you 1, okay. Then it means these degrees here, they give us the same solution, even though this one is in the next cycle, okay. It means even if you can have another cycle here, whatever degrees that you're going to have here is going to give us 1, okay. It's going to give us 1. So these cycles or these waves, these other waves, they are taken care by the k, okay. That's why here we included the value of k, okay. Here, that's why here we are having the value of k, okay. The value of k is taking care of other cycles, okay. Then we can have another cycle in this direction, okay. We can have another wave in this direction, okay. Whatever is going to be here, the degree is going to give us 1, okay. Then it means we are having the same solution, okay. Even if it goes like that again, the degrees here, the, the degrees here, they're going to give us the same solution, okay. Then if you are heading this direction, obviously it's the negative direction, then your k should be negative, maybe -1 and -2, okay, like that. So that's why they say this is a general solution. It generalizes all other solutions in other cycles or waves, okay. This one is the solution in the first wave, okay. Then if you want other solution in the second wave, third wave, in whatever direction, then this takes care of that, okay. Then let's go for the second quadrant, because that's where the sign is positive also. Then you're going to have the x. In the second quadrant, you are having 180 degrees, subtracting the reference angle there, okay. Then we are still having the k 360 degrees, whereby k is element of integers. Okay, here you can simplify this. You can have x equals to k. Let me just squeeze it here. You can have x equals to k 360 degrees, because here is just 0. Okay, you can simplify it like that. Okay, then here you can simplify this one to 180 degrees, then having the case of multiplying the 360 degrees thing. Okay, then we are done with the general solution for the sin x equals to 0. Okay, then let's go to this one. Let's try this one. Okay, if this one we are having the cos x there, the cos x there be equals to -1/2. Okay, then again we start with the reference angle. Okay, with the reference angle we ignore the sign. Okay, this sign tells us about the quadrant. Okay, we are will literally just solve for whatever this here, the angle here. Okay, then obviously we are going to introduce the arc on the other side. On the magnitude we ignore the sign. Okay, then here I'm going to have the arc of cosine of what, 1/2. Okay, I've ignored the sign because the sign tells me about the quadrant. Okay, then here I must punch in the calculator to say the shift, then I got the arc of what, 1/2. It gives me 60 degrees. Okay, then here I should have 60 degrees as my reference angle. Okay, then I ask myself which quadrant is actually cos negative. Okay, then I remember very well that cos is negative in the second quadrant and third quadrant. Okay, then let's start with the third quadrant. Okay, then here whatever this here you take it to the left hand side. Okay, and then here we are in the third quadrant. You are in the third quadrant. Actually, we're supposed to start with the second, but it doesn't matter. Okay, then in the third quadrant, we are having 180 degrees plus what? The reference angle. Then we are having plus 60 degrees. Okay, then here we are having the cosine. The cosine also completes the circle after 360 degrees. Okay, 360 degrees. Then where k is element of integers. Okay, even this one here still takes care of other solution in other quadrants. Okay, then here myself for how much, 240 degrees plus k multiplying the 360 degrees. Okay, that's the general solution in the third quadrant. Okay, then in the second quadrant I'm going to have 180 degrees subtracting the 60 degrees. Okay, the 60 degrees is the reference angle plus k multiplying the 360 degrees. Then we're having k being element of integers there. Okay, then here must have 120 degrees plus k multiplying 360 degrees. Okay, those are our general solutions in these questions. Okay, we are done like that. Okay, we are done like that. If you have any question, you can post so that we can clarify. Okay, we started here and we went there and we got some more here, and then we came here to the cosine and to the sine also. Okay, even here to the sine also. Okay, bye.